Graphical Methods KCSE 2007 Paper 2 Question 23. The table below shows the values of the length x, in meters, of a pendulum and the corresponding values of the period t, in seconds, of its oscillations obtained in an experiment. X, meters. 0.4, 1.0, 1.2, 1.4, 1.6. T, seconds. 1.25. 2.01. 2.19. 2.37. 2.53. A. Construct a table of values of log x and corresponding values of log t. Correcting each value to 2 decimal places, 2 mark. B. Given that the relation between the values of log x and log t, approximate to a linear law of the form log t equals log x plus log a, where a and b are constants. I. Use the axes on the grid provided to draw the line of best fit for the graph of log t against log x. 2 marks. 2. Use the graph to estimate the values of a and b, 3 marks. C. Find, to 2 decimal places, the length of the pendulum whose period is 1 second. 3 marks.
That's the question. So let us go direct to the first part of the question, and that is constructing a table of values of log x and corresponding values of log t, correcting each value to 2 decimal places. So let us go direct to that. So logarithm of the first one, which is logarithm of x, the first value of x in meters 0.4. So logarithm of 0.4 will be negative 0.40, negative 0.40. And then we have the next one, which is a logarithm of 1, which is 0. Then logarithm of 1.2, which will give 0.08. Logarithm of 1.4, 0.15. Then logarithm of 1.6 is 0.20. That is the column of log of x. So logarithm of t. So the first one is logarithm of 1.25, which is 0.10. Logarithm of 2.0, 2.01, 0.30. Then is logarithm of 2.19, 0.34. And then we have next one is logarithm of 2.37, 0.37. Logarithm of 2.53, 0.40. So that is the first thing you're supposed to do, creating the table of logarithm of x and logarithm of t. So let us plot log t against log x. So what does that mean? Log t against log x means log t will be located on the y-axis, and then log x will be located on the x-axis. That is what we mean by log t against log x. So before we draw our lines on the graph, before we do that, there's something that we need to do here. We need to decide on the suitable scale. So looking at the values of log x and log t, and looking at those values there, we decide the scale by checking the lowest or the least and the highest value. So for log x, the least value is -0.4, the highest is 0.2. For log t, the least is 0.1, and the biggest value is 0.4. So those will help us to decide the scale. And when I look at these values, the best scale to use is 1 centimeter to represent 0.05. That will work for both axes. So you need to draw a line. In order to accommodate these values, you need to leave a space on the left hand side of the x-axis, since that is why I have -0.4. So we draw the axis. So this is the y-axis, and then here we have the x-axis. So we've decided the scale. 1 centimeter should represent 0.05. So there is 0.05, 0.1, 0.15, 0.2. Then the left hand side, that is how we have many values up to -0.4, and these will represent, for the x-axis we have log x, don't forget that, and then for the y-axis we have log t. We have log t there, the y-axis. So these would be -0.05, -0.1, -0.15, -0.2, -0.25, -0.3, -0.35, then -0.4. So that is the x-axis. That is how it should be. We have log x. Then the y-axis, for the y-axis, 0.05, 0.1, 0.15, 0.2, 0.3, 0.35, 0.4. Oh, there's something here I've left. So here you should have, from 0.2 should have 0.25, then this one should be 0.3, 0.35, and then 0.4. That is clear now. So that is clearer. So now you can see the scale. So I've corrected here. So this is 0.25. So 0.5, 0.05, 0.1, 0.15, 0.2, 0.25, 0.3, 0.3 only, then 0.35, and 0.4. Now let's go to plotting now. The first value is -0.4, 0.1. -0.4 is here, -0.4 is here, the extreme end. Then I should go with 0.1. 0.1 is there. Then 0 is here, the center, 0 and 0.3 should be there. That's where it should be. 0, 0.3. should be here. This is where the point should be. And then the next one is 0.08, 0.34, 0.08. Now one small square will be 0.01. Since 1 centimeter represents 0.05, one small square inside that will represent 0.01. So 0.08 will therefore be here 0.08, 0.34. So 0.08, 0.6, 0.7, 0.8. Then 0.3 is here. 0.6, 0.6, 0.8. Then 0.3, 1, 2, 3, and 4. It should be here. So that point now represents 0.08, which is 0.0678, then 0.31, 0.32, 4, and 5. 4 will be there. Then the other one is 0.15. 0.15 is here. 0.37, 0.37, 0.35, 0.6, and 0.7 should be there. The last one is 0.2, 0.4 should be there. Now you can see the line of best fit. The line of best fit now is visible, or the 4 points, the 5 points. We should have 5 points, 1, 2, 3, 4, 5. So the first point is here. The other one is here. Then the next one is here. The next one is then there. So drawing the line of best fit. This is a line where most of the points should lie on that line. And when I draw these, these already should get at least most of the points should lie on that line. Most of the points should lie on that line. So when I look at I can see 1, 2, at least 3 points are lying on that. Very few points are not exactly lying on that line. Just 2, but 3 are there. So that is what we call the line of best fit. The line in which most of the points that you have plotted are lying on the line. So as you can see, we have this point is on that line. We have this point is on that line. Then we have this point. The last point is still on that line. So that is how you basically draw the line of best fit. Now after drawing the graph, that's the line of best fit, the next question you're supposed to do is use the graph to estimate the values of A and B. So how do we estimate the values of A and B? And this is the equation. This is the linear law connecting the two. So logarithm of t is equals to b log x plus log A. Now having these, how do we determine the values of these A and B? This is the graph that we drew. This is the linear graph, the line of best fit. Now this is what you do. When you look at this line is expand this a little bit, make it bigger. Now when you look at this equation, try to relate this equation with the equation of a straight line. And when you do that, when you compare y is equals to mx plus c, there's something that you would notice that b will automatically be the gradient, and then log A will be the y-intercept. When you relate the two equations, the equation of a straight line and this equation in terms of log, this is what you notice. So to get B, that will be the gradient of this line, to be the gradient of that line. And then log A would be the y-intercept, that is a point where that line cuts the y-axis. Now begin with B, which is the gradient. So B is the gradient. And how do we get the gradient? We get the gradient of a straight line by getting 2 points on that line. So I want us to obtain 2 points on that line and use the 2 points to calculate the gradient. The first point you're going to use is negative 0.4 and 0.1 and 0 and 0.3 points that lie on that line, just 2. So we've picked 2, negative 0.4 and 0.1 and 0 and 0.3. Those are the 2 lines that I want us to pick. So gradient is given by, so we're going to, B is the gradient, that is the first thing we have said, and these are the 2 points that you want to use. So negative 0.4 and 0.1, those points, and then 0 and 0.3. So we want to use these two. So B, which is the gradient, will therefore be given by change in y, which is 0.3 0.1 divided by change in x, 0 subtract negative 0.4. So this will give 0.2, 0.4, and this will give 0.5, which is a half. So that is how you're supposed to work out that. So definitely, as you can see, we've been able to establish the gradient of that line. I want to create more space here. Let me get more space to work out. So I think that is enough. So that is the gradient, so therefore B is equals to 0.5. Now log A is the y-intercept, and the y-intercept is the point where the line cuts the y-axis. So that line cuts the y-axis 0.3, 0.3. So therefore 0.3. So log A is equals to the y-intercept, and this y-intercept is log A is equals to 0.3. That is the point where the line cuts the y-axis. That is the y-intercept, 0.3. And so if you are to obtain if you are to get A, how do you get A? You get the antilog of 0.3. You get the antilog of 0.3. So A will be given by, when you get the antilog of 0.3, you get approximately 2 decimal places. The question you're required to, you're going to leave it in 2 decimal places. I've seen it somewhere, because we are filling the table correct 2 decimal places. If you write these, the value of A 2 decimal places, you get, but first you get 1.995, that is 4 significant figures, and approximately 2, 2.00, that is to 2 decimal places. So that is, we've been able to identify the value of A and the value of B as well. So B is the gradient and A is the y-intercept. Now find 2 decimal places the length of the pendulum whose period is 1 second. Find 2 decimal places the length of the pendulum whose period is 1 second. So what you're going to use is this equation. We are going to use this equation that is here. Log t is equals to, this will help us, log t is equals to b log x plus log a. So t is equals to 1, and this tells us that when you're getting the log of t, this will be the log of 1, and the log of 1 is 0. So when it comes to substituting these values in this equation, this is what you're going to have. Log t will be 0, that is the log of 1. Then we obtained b as 0.5, and then log x is what now is going to give us the length of the pendulum. So, and then log a, logarithm of a is 1.995, so logarithm of a will automatically be 0.3. Let me go back there. So logarithm of a is here, logarithm of a is 0.3, so you just need to substitute there. So when you substitute these values in this equation, we'll be left with log x, and x would give the length of the pendulum. X is what you are looking for. So define x. So we solve this equation. 0.5 log x is equals to, this will give negative 0.3, and working out these, this is what you're going to get. Log x is equals to negative 0.3 divided by 0.5. We get logarithm of x will be given by, when you substitute these, we get negative 0.6. How do you get x? X will be given by the antilog of negative 0.6, and these will give 0.25 to 2 decimal places as the length of the pendulum.